Okay, so I wanted to make this video to cover a couple things that we didn't get to at the end of Wednesday's lecture. So one of the things we've been talking about is the connection between slopes and areas. So we previously saw that velocity was the slope of the position versus time plot, right? And we got to this from our equation for the average velocity. If the average velocity in the x direction is the change in x over the change in time, if I look at a plot with the position on the vertical axis and time on the horizontal axis, and I look at an initial point and a final point, the slope, which is that change in x, right, the change in height divided by delta t, right, or the run, that's going to equal the velocity. We just saw today that the change, or not the change in, but the area under the velocity versus time plot gives the change in position. Right, so if I think of my change in position as the average velocity times the change in time, that looks like an area on the velocity versus time plot, where I've got my velocity here is like my height of this area between the 0 and the function itself, and I'm going to multiply by the width from 0 seconds to 2 seconds. This turns out to work for any quantities related by a slope. Right, so I can go back and forth. Since I know velocity is the slope of the position versus time plot, I can find the change in position by looking at the area of the velocity versus time plot. So for example, we know that acceleration is the slope of the velocity versus time plot. All right, so my average acceleration in the x direction is the change in the x velocity divided by the time. So again, if I look at a velocity versus time plot, right, I'll get my slope, which is the average acceleration. Again, that's the change in velocity, so the final minus the initial velocity divided by the change in time. Should be the final time, there's the initial time. Using a similar relationship between acceleration and velocity as we did with velocity and position, the area under the acceleration versus time plot will give us the change in the velocity, just like the area under the velocity versus time plot gave us the change in position. Right, so the change in velocity in the x direction is the average acceleration times the time. So if I look at an acceleration versus time plot, I can see the acceleration is like my height. I multiply by time, which is my width, and that will give me my change in velocity. So again, this works for any quantities related by a slope. There's also one of the clicker questions we didn't get to that I thought would be useful to do in the video. So we want to find the average velocity from 0 to 5 seconds. All right, so I'll recommend that you pause the video now to see what you might think. We've got a plot that starts at 1 meter per second here. This is velocity versus time. And then at 2 seconds, it drops below down to -1 meters per second and keeps going. And we want to know the average velocity from 0 to 5 seconds. So go ahead and pause and try and see what you think. Okay, so let's take a look at what we're going to do. We need to remember how average velocity is defined, and I'll go ahead and get a little ballpoint pen, and we'll make it so it's not red, a little blue. Okay. So we want to remember that average velocity, remember, is our change in position or our displacement divided by the change in time. So I want to find the change in position from 0 seconds to 5 seconds. We can do that by looking at the area. So first I'll find the area for this part of the plot. So for this first part, I've got 1 meter per second. Times 2 seconds, which is 2 meters. For the second part, which will be from 2 seconds to 5 seconds, I have -1 meter per second, because that's the velocity down here, right? It's -1. Times 3 seconds, because I'm going from 2 seconds over to 5 seconds. So that gives me minus 3 meters. So if I go up here, I've got 2 meters plus minus 3 meters for my total displacement, and that's in 5 seconds. So I get minus 1 meter divided by 5 seconds, which gives negative 0.2 meters per second. So we should have choice E. So remember, we did that by finding the total displacement using our area ideas with the velocity versus time plot. Once we had the total displacement, we were able to divide by the total time that we were asked to find the average velocity over. And that should be it for this video. Hopefully it was helpful. Let me know if you have any questions.